Welcome. We are going to be finishing up the rest of the test review. Most of these questions, the ones you see solutions to, we've already worked them during class, and one of the benefits I want to give you is the ability to see the rest. So we're going to go ahead and continue with this. On question one of the questions we didn't fill out, they're asking us to solve for the 6 trig functions. In order to do that, we're going to go ahead and write down, like I'll start with cosine. They want us to find out cosine of type 2 pi over 3. They want us to discover the solution to sine of 2 pi over 3. And also the result of tangent of 2 pi over 3. And these are the first three main ones. Now the thing I love about these three is that we have it that they're pretty much just available. Like when I pull up my unit circle, I'm going to go ahead and identify 2 pi over 3. Now let me erase. This was in regards to angles. But what I want to make it clear is that we have the benefit of knowing that this is 2 pi over 3. And this is cosine, this is sine, and this over here is tangent. This is what made the unit circle so powerful and beneficial to us because it could quickly give a solution. So now I could prove to you that the solution for cosine is negative 1/2. The solution for sine is square root of 3 over 2. And the solution, the box one that you have on the outside, is going to be negative square root of 3. Now, if you don't have all these values, these angles, or the radian measures, pause the video, copy it down, make sure that it's correct because you're going to be able to use the unit circle on your exam tomorrow. And that's going to be important as far as getting these solutions. So let's write down negative square root of 3. Now, the thing I love about this is that once you have these values, you look at the reciprocal values of each one. And in a simple and easy format, they're going to be just the instead of, they're going to be kind of like just switched around. They're going to be, we have the benefit of just, instead of having negative 1/2, it would be negative 2 over 1, which solution is negative 2. Instead of having sine of 2 pi over 3, it's going to be the reciprocal value, which is going to be 2 over square root of 3. Now with this one, if you ever see if you have a radical in the denominator or a square root in the denominator, we do this process called rationalization. And what it does is it gives us the benefit instead of square root of 3, solution comes out being 3. And the last one is cotangent of 2 pi over 3. And we discovered that it's negative 1 over square root of 3. So square root of 3, square root of 3, negative square root of 3 over 3. So there's a solution. Now let's go ahead and move forward to the next ones. Let's see, I think, did I do all these? Yeah, I did number 2. Now let's work on 3. Now, on 3, they're going to asking us for 3 cosine of 180 degrees. This is where we bring out the unit circle. We look at 180, which is right here in this case. Go ahead and go this to right. And this is cosine. So I'm going to use negative 1. So let's go to and write down negative 1. And then they want us to find the sine of 45 degrees. So I'll go back to the unit circle. 45 is right here. This is sine. So square root of 2 over 2. So then I'll discover over here that this is square root of 2 over 2. Now from here, this becomes negative 3. You see this 2 and this 2 right here? They cancel out because this is literally a fraction multiplied by a fraction. It's just that we never really think about 2 as a fraction just because it's not necessary until something like this arises. But with the cancellation, we have the benefit of seeing it like this. And this is the actual solution to it. You can't combine these. So from there, we leave it like that. All right, now let's go ahead and find out this next one. They want us to find the 6 trig functions of this angle. This is where it becomes very powerful and beneficial to write SOHCAHTOA because this is going to be my angle measure. And from there, I'm going to go ahead and discover all the values. Now the only thing that I need to do is I need to find out this missing value because I do have a value. The opposite of that angle is not there. And we have the power that if it's a leg, if you are not taught the shortcut, you could start by Pythagorean theorem and discover this shortcut. Eventually you're going to end up with this, that your leg, which is the base in this case, is going to be the square root of the hypotenuse squared minus the leg squared. So then I could go ahead, actually that's not going to be squared there. But this is going to be 25 minus 4, which comes out being the solution of square root of 21, square root of 21. So from here, I could go ahead and now discover the solutions to this. Like we're going to go ahead and move forward and see it's going to be opposite, so square root of 21 over hypotenuse, which will be 5. Cosine's adjacent, 2 over 5. Tangent is opposite. And you know, one of the things I could do is for those that are possibly struggling with this, it's probably beneficial to write down the actual values. And it goes in order. So for those that may have missed that in regards to this, this is how we get these values. Adjacent over hypotenuse, so it's going to be 2 over 5. Tangent's opposite over adjacent, so square root of 21 over 2. The thing I love about this, which makes it kind of easy to do, is that these are just reciprocal. So this will be h over o. So 5 square root of 21. We are going to go ahead and rationalize that. 5 square root of 21 over 21. Let's see, h over a. 5 over 2. A over o. As you see, they're all just reciprocals, 2 over square root of 21. So again, this is just going to become 21, 2 over square root of 21. And that's the solution to that. Okay, let's move forward. Okay, we did this one. Now let's find the grade of a mountain trail. So a straight trail with a uniform inclination of 18 degrees leads to a lodge and elevation of 500 feet to the mountain lake and elevation of 1,000 feet. Okay, and what is the length of the trail? Now this one contains a few things. Now one of the things that when we talk about elevation that is important for you to know is that for the most part, you got the sea level, that's at 0. That's when you're at sea. Here in San Antonio, we're about 1,000 feet above sea level.
Good morning, teachers.
And hold on, let me pause this. Okay. Here in San Antonio, we are about 1,000 feet above sea level, which means that, and so this is like somewhere, if you're going to relate, you're somewhere at about 500 feet. There's the trail, 18% inclination. But what's important is that the height of it's 1,000 feet. So you subtract both, we discover that this is about 500 feet of what you travel from the lodge over to the end of the trail. And hold on. So from here, let's they're asking for the elevation of the actual, or the distance of the trail. So that's going to be the actual trail, because that's exactly what you're going to be walking on as you travel up. So one of the things that we discover is that this is going to be opposite over hypotenuse. So in writing SOHCAHTOA, the sides that we do know is these two. So I'm going to be using sine to solve for this. So let me go right over here. Sine of 18 degrees. It's going to be opposite, which is 500, over hypotenuse, which is my x. I'm going to cross multiply and divide. So 1 times 500. Move this out. 1 times 500. We know it's going to be 500, but the important part is that we're doing the order right, sine of 18 degrees. Now, I'm writing these things down, but it's going to be important for you on the test to make sure your mode is in degrees. If it doesn't, it's not going to give you solutions like this. You're going to get some odd solutions that don't seem reasonable. Ain't good thing to check your mode. All right, so the not the square footage, but the length is 1,618.03. So 1,618.03 is the actual solution to this. All right, now let's go ahead and move forward. And let's see, these other ones right here. Okay, so the one that I didn't do is this one. I think the ordering starts going a little unusual here just because I didn't want to reprint all new copies, but still all the questions still remain the same. On this one, 120 degrees, in order to find the angle on this, remember terminal side, this is called, says they want to indicate the initial side, so this is initial. This is standard position. terminal side, this is roughly about 120 degrees, so you write down terminal. And then you draw the angle that goes there. So 120 degrees. That's the angle. There we go. Pretty easy. Now, this one, they want us to convert from a decimal degrees, or from degrees, minutes, seconds to decimal degrees. And what's important about that is that there's 60 minutes in a degree. So that's why we have the benefit of just taking the 35 minutes, dividing it by 60. And we know that 3,600 degrees in seconds. So it's a pretty simple solution. Bring out your calculator. Type that in. So we're going to type in 77 plus 35 divided by 60 plus 40 divided by 3,600. So we got 77.59. So there we go. So 77.59 is the actual degrees there. You write to 2 decimal places. So there we go. All right, so now when we have to go the other way around, slightly different. We're going to go ahead and actually take 72. You put that separate from the decimals. Now you take the decimal part, and you're going to multiply that by 60. And the solution that it produces, it's going to have both the minutes and seconds in it. Actually, mostly minutes, because it's going to give you the minutes in the format of the minutes. So it's going to be a fractional sense. So it's going to be 0.367 times 60, 22.02. So in minutes, it's 22.02. Now I want to take the seconds portion, so it's really these 0.02 portion. And we're going to multiply it by 60 again, and that's what's going to actually take the portion represent seconds and tell me how many seconds it is. So move this out of the way. So let's have the benefit of writing that down or seeing what the solution is to that. And it's actually this 60 and this 60 that makes the 3,600 in this last portion there. So 0.02 times 60, 1.2. So we round 1 second. So this is what you write down. 72 degrees and 22 minutes, 1 second. And that's the solution to this portion right here, to that problem. All right, now let's go ahead and finish the conversion of the last two. And one of the benefits we have from here is that when we want to convert from degrees to radians, you're just going to multiply by pi over 180. The easiest thing to do is to math bracket. It's a quick and simple solution. So like when I sit here and I do this, I do 210 divided by 180, math bracket, 76 pi. So you take the fraction you get from here, because we're going to express pi in its actual pi. So 76 pi. So you write next to it. And from there you'll get that solution. It looks like that. All right, now let's do this next one. Now on this next one right here, and on this final one, you're going to go ahead and take this, and the conversion is 180 over pi. So let's see, we're going to have negative 2/3 times 180. And let me explain something. Let me preface something important. These pi's are canceling, because this is a fractional, so that's a numerator, the other one's a denominator, and what we're left is really numbers I need to be expressed like this. And what's left over is negative 120 degrees. And it's okay to have a negative number, but that's the solution in itself. All right, I hope this review and everything else is helpful to you. All the rest of the solutions are placed in here if somehow you missed and need to get them. If you have any questions, feel free to visit me.